Got a small garden? Considering a vertical? Here's some myths and tips from Waters and Stanton Limited, your ham radio dealer.
Hello and welcome to the Waters and Stanton video channel. My name is Peter Waters and my call sign is G30JV. I'm going to talk about verticals today, vertical antennas, particularly aimed at beginners and those with small gardens. There's two basic reasons why you will want to install a vertical antenna. The first is because you fancy the idea, and the other one is because you have to, probably because you've got a small garden or there's some planning regulations that you want to try and overcome. So let's talk about the vertical antenna. Let's first of all, let's go right to the beginning and see how the vertical antenna evolved. Now, I think that a lot of you will be familiar with the dipole. Put up on the screen here, picture of a dipole. It's a classic antenna. It's been around for, well, almost since the beginning of radio, really. Hundreds and hundreds of antennas use the dipole configuration. And basically you've got two arms that are horizontal and you feed it in the middle with coax cable. Now, we're not going to talk about the niceties of balance and so forth. We're going to keep this really simple. We're going to talk about a dipole to start with, fed with coax cable. A dipole will give you various degrees of radiation angle depending on how high it is above the ground. And the aim has always been, particularly on the higher bands, to get it at least a half wave above ground. So on 20 metres it's got to be 10 metres above the ground. But when you come to the lower bands, of course, it starts to become, the height starts to become unmanageable for most of us. Now, we can actually see how the verticals develop by, let's look on the screen again. Now you see here, what I've done now is I've lowered one leg of the dipole, so it's around about half a metre, say, above the ground, and I've brought the other leg up vertically and brought it down to meet the lower horizontal arm. So basically now you've got a vertical antenna which is got a radial. We call that horizontal just above the ground, a radial. We've got a vertical antenna with a radial about half a metre or 1 metre above the ground. Now that actually will work quite well. And what happens now is the angle of radiation has been reduced to something like around about 20 degrees or so. So instead of having a radiation angle which you might have on a low dipole, say a quarter wave dipole, you've got a fairly high angle of radiation, maybe 50 degrees, 45, 50 degrees. With the vertical that I've put on the screen now, you've got a lower angle radiation of around about 20 degrees. It's not a sort of a sharp angle, it's sort of blurred, you know, it's sort of got rounded edges, it's sort of brushstroke. But basically it's centered around about 20 degrees. Now, the advantage of a lower angle of radiation, of course, is that it hits the reflecting layer at a lower angle and therefore it bounces back to Earth at a greater distance, because as you lower the angle of radiation, so the signal that is reflected off the upper layers, reflective layers, travels further, so it's good for DX. It is not quite so good for close-in work, of course, because you have this skip distance which was created by the wave going up, hitting the atmosphere and down, and the piggy in the middle misses out. So we have basically a vertical antenna which is resonant, well, let's say it's resonant on 20 metres. So we've got a vertical element which is quarter wave, 5 metres tall, and we've got a horizontal element which we're going to call the radial, 5 metres long. Now, the good thing about that is it works. The only problem is that it will only work on one band. And if we were to alter the length of that radial, it's almost the same as altering the length of the vertical element. We change the frequency. So we need the radial to be identical in terms of length to the vertical. We could try and make it multi-band by putting a trap in. So look, I've put on the screen now a picture of that vertical with a trap in. So let's say it operates on 20 metres and 15 metres because we've got a trap in there. Problem is that radial is resonant on 20 metres. So whilst it will work quite well on 20 metres, it won't work on 15 metres because the radial is the wrong length. It'll throw the whole matching of the antenna out of kilter. And in actual fact, effectively what it does, it moves the feed points along a bit. We won't go into that. Basically, it'll work quite well on 20 metres, but on 15 metres it won't work so well. So we start to have to consider radials that are raised above the ground. Now, if you've got a small garden, that's entirely unattractive. You don't want to have 5 metre radials, or whatever length they need to be, around the garden, half a metre above ground. First of all, in a lot of gardens it will be impractical, and secondly it would mean to say that if you ever had a lawn, you'd have to take them down every time you cut the lawn and it would look a bit unsightly. Okay, so we'll scrap that idea. What about if we move the antenna down to ground level? So we move the antenna down to ground level. That radial, that horizontal, starts to become non-resonant. When you place a radial on the ground, the resonance is really blurred. It's coupled into the ground, and the whole ground and the radial tends to be one massive, great big radial that will resonate in all sorts of frequencies, wide band. So all of a sudden, our quarter wave vertical with a trap in the middle will start to work on 2 bands. Now, because that works, we could add traps. And in another video, I'm going to talk about a very popular antenna, the Hustler, which is made in the USA and covers 40 through to 10 metres. And that may well be a serious option for a lot of you. But anyway, we know now that we can add traps to that antenna and it will work. If you've read anything about vertical antennas, you'll see lots of advice about radials and the importance of radials. Certainly the ground is critical. A vertical antenna does need to work against ground because the ground is really the other side of the antenna. But there's a few myths, and there's often words of warning, dire words of warning, that it will only work if you do this and you do that. The popular, well, it's not a myth exactly, but in some ways it is. The popular recommendation is you want to get as many radials as you possibly can, quarter wave radials along the ground. Well, first of all, as soon as you lay a radial on the ground, it no longer resonates at the frequency you might think it would resonate at. So if we go back to 20 metres, again, you put a 5 metre length of wire on the ground, it's not going to resonate at 20 metres. It's going to resonate somewhere lower, and in fact it's going to be a very, very vague resonance, because it'll be coupled into the ground. I can remember seeing something that said you need 128 radials, quarter wave long, in order to get the best out of a vertical antenna. Well, I'm not quite sure whether that's true or not, but it is totally impractical for you and me. We're not going to have 128 quarter wave radials on the ground because we haven't got a garden big enough, and really and truly, is it really justified? I'm going to shock a few of you by saying that a vertical antenna will work with a ground rod. That's right, a vertical antenna will work with a simple copper ground rod driven into the ground beside the vertical. Just get yourself a copper rod from B&Q or whatever, hammer it into the ground as far as you can, and connect the outer sheathing of your coax cable to the ground rod and the inner conductor to your vertical. Yes, it does work. And how do I know it works? Because I've tried it. I've used it in the past when I've been hard pressed for antennas. I've put a ground rod in the ground and connected the coax cable, the outer sheathing to the ground, and the inner conductor to the vertical antenna. Shock horror. Yes, I know there'll be all sorts of people probably writing in and saying, oh, this is ridiculous, it can't work, it's inefficient. Well, it may be inefficient, but it certainly works. So let's get back to radials. How long should they be and how many do you need? Well, one radial will work, it'll get you started. It'll be slightly better than your quarter wave, your copper ground post driven into the ground. 3 or 4 will work better. Once you get to 3 or 4 radials, you've got a system that is not too bad. And I've used a vertical antenna over the years with just 4 radials. What length do they be? Well, it's not actually as critical as you might think. In actual fact, the radial length I don't think is critical at all. It is often just as good to have 10 or 15 short radials than it is to have 3 or 4 long radials. And in fact, I've heard a number of stations that I know for a fact are using short radials working extremely well. It's not impossible on a small garden to put out 10 or 15 radials, say 3 metres long, 3 or 4 metres long, and it works well. It works well. Does it work as well as the 128 quarter wavelength radials? No, it probably doesn't. But I would venture to say that the difference is not as great as some people would have you believe. So if you're going to put a vertical up and you're considering putting a vertical up, don't be deterred by the recommendation that you have to have 128 quarter wave radials, because you don't. In my experience, the law of diminishing returns rapidly comes into play. Once you've got more than 5 or 6, 7 or 8 radials, then the law of diminishing returns comes into play, because you've really got to double the number of radials to notice any difference. And it's very difficult to evaluate the difference. My own personal opinion from experience is that use more short radials than just a few long radials. Now that gives hope to those that have got small gardens. If you've got a small garden, and if you can get a radial out to about 3 metres long, then put as many as you can out, and that antenna will work. Now, just one other thing which I'll touch upon in more detail in another video. Traps. Often people will say, well, if you've got a trapped antenna, it's going to be lossy. Well, I've never read anything that actually sets out to try and measure the losses in traps. Somebody once said, well, traps don't get hot, so they can't be lossy. Well, traps, generally speaking, are made of aluminium, and aluminium is not a particularly good heat conductor anyway. My experience, again, based on my own experience, and also the fact that there's hundreds and hundreds and thousands of trap aerials about, trap Yagis and so forth, that work extremely well. If there is a loss in a trap, and there must be a loss in the trap, if there is a loss in the trap, it's not terribly significant. The trap antenna will work quite well. If there is any inconvenience, it's the fact that a trapped antenna will be less broadbanded. It'll in other words, it'll cover a narrower band of frequencies, because the traps tend to be fairly high Q and they'll only work properly over a narrow band of frequencies. But is that important? I mean, if you've got a vertical on 40 metres, trap vertical on 40 metres, that's only got a bandwidth of 100 kilohertz at the 2 to 1 SWR points, does that really matter? Is that the end of your life? Is that ham radio over for you? No, of course it's not. You've got 100 kilohertz of band in which to operate in. And in actual fact, you can move beyond that 2 to 1 point. If you've got an antenna tuner built in the radio, which a lot of radios have, they'll cope quite happily with 2.5 to 1, even 3 to 1. And the losses you get on the coax, and this is a really long run of coax, will be minimal. So let's summarise. If you've got a small garden and you want to put a vertical up, then I would say that you need a self-supporting vertical. Again, I don't mention Huxley because it's self-supporting. You don't need guys on it, and if you use the radials that I recommend, like 10 and 3 metre radials, it'll probably fit into most gardens. Okay, you put it over to one side of the garden. Okay, so those radials only cover 180 degrees. Well, okay, so what? it'll still work. Those radials will couple into the ground. You've still got next door's ground to benefit from. Yeah, you know, a wooden fence doesn't stop radio signals. You've got next door's ground, which will effectively be helping the antenna. So don't give up. Consider a vertical if you've got a small garden. Don't believe that you've got to have long, long radials and hundreds of them. That's nonsense. You don't. It may not work as well as the theoretical 128-degree radial, but I would question what the difference is. Not as much as you might think. Okay, right, I've gone on a bit. I hope it's been interesting. I hope it's been useful. I hope it's given you some encouragement. So as usual, thanks for watching this video. And if you have enjoyed it and you want to keep in touch, then press the subscribe button. But until next time, enjoy your ham radio, keep safe, see you soon.